So I'd like to welcome one of our sponsors, Do IT Now, Danilo Gonzalez.
Thanks for the introduction. So today I want to talk a little bit about an agnostic Appstack. It sounds fancy things, but I will try to introduce a little bit about it. But just to start, I want to talk a little bit about us. We are Do It Now. We have offices in Germany, Italy, France, and Spain. And in the HPC and the AI ecosystem, we offered complete solutions. What it means, we offer consulting, installation, and maintenance. It involves anything that you need to start working on AI or an HPC. So as I said at the beginning, I will talk a little bit about software, so in specific for scientific one. So scientific software commonly relies on multiple projects that we know as dependencies. But sometimes dependency resolution is not really straightforward. And you can face an event that is known as dependency hell, that you cannot even install a package from source. So there are some solutions available, that is, or ways to avoid it, that use containers or precompiled packages or conda environments, among others. There are several options. So how scientists use the scientific software? So there is an ideal workflow. The scientist has a raw data and wants to get a fancy plot. So in an ideal workflow, we have 3 steps: that preprocessing, processing, and plotting. For the preprocessing, they use default packages that is available in the system to read, write files. For processing, they use containers, and finally, to get the plots, they use a conda environment. It's just an example. But in real life, it's not as simple as this one. It's more like this. So you have packages, containers, conda environments along the workflow. So it's quite difficult. So it's a complete mess. I represent it in that way. So why, if we want to upscale this mess or these pipelines to even to other workstations or to HPC or even a cloud system? What happened is that the portability is not guaranteed. Why? Because the nature of the way that the Appstack is built or the scientific software is available. So maybe it's easy to be available in other laptop or in other workstation, but when you migrate it as it is into an HPC, you can maybe have a functional one, but it's not the optimal solution because it's using all the instruction sets or whatever, or even the worst case, that is even not functional. So ideally, the ideal portability is that you can use the same Appstack or have the same experience in each case. So there are solutions for it. So one of these solutions is EESSI, that is also already mentioned for one of the previous speakers. That is an European environment for scientific software installations. That is an initiative that is a collaborative one between companies and academia, to have a portable and performance scientific Appstack. So this is some of the partners that you have: universities, infrastructure providers, supercomputing centers, and so on. So why this is an agnostic Appstack? So the main goal here is that you can use it everywhere. So we support now Intel, AMD, ARM, and we are working on RISC-V support. So the host IS will provide the basic drivers, like network drivers, GPU drivers, and the Slurm and the queue manager. So in this case, it's Slurm. I will put whatever. We have been tested in Linux and MacOS and Windows subsystem Linux. So it covers a large part of the scientific environment. So on top of it, we have a file system layer. That is the way that we distribute the software Appstack. That is the CERN's BMFS. That is a way to stream, in this case, scientific software along any client. On top of it, we have the compatibility layer. This compatibility layer is the thing that do the magic here. So in this compatibility layer, we have a set of packages that ensures that the Appstack could work everywhere. So it's built on top of Gen2 prefix. And on top of it, we have the software layer that is the optimized application and their dependencies. So we use EasyBuild, Archpack, and LMOD to provide the environment. And all this environment is tested using Reframe framework. So in such way, you can have an Appstack that once you try to test it in your laptop, it will select the proper architecture of your CPU, in this case, and you have the best performance that you can achieve in an easy way. So without easy, you have the previous case that I mentioned, that is a non-functional or even not functional, and you can have a ideally perfect scalable pipelines. So it's a good solution for all of the users. And this is EESSI initiative will provide software for multi-scale project. Multi-scale is a Euro HPC center of excellence to deploy some software to be available to be used in pre-exascale and exascale HPC systems. So I put two examples, Espresso and Lamps, among others. And the goal here is that we put this software and we optimize. We're working with SECAM Center to optimize this software, and we put it into EESSI. And then this software can be streamed into Euro HPC systems and also on other systems. What is the main goal here? That if you have a scientist that has, for instance, a grant for use Carolina HPC cluster, he can move to another Euro HPC system and can use the same software stack without any issues. So it's really making science a little bit easy. So it sounds really, really nice. So if you want to have more information, you have the QR or the web page about it. So what about these tools for an external use? So a more a company use in this case. I want to talk a little bit about our experience providing EESSI-like solutions for a pharmaceutical company. So first, describe a little bit about the pharmaceutical company. So they want to have an Appstack that should work everywhere. They face the problem that I mentioned before that was quite complex to escalate pipelines. So this is an example. They have clusters along the world that are managed by different groups, and they want to have it on cloud. They also want to have it on workstation, on laptops, so the scientists can do their job easily. So in this case, it's like a ring to rule them all. What they need a proper custom solution because public distributed Appstack will not match. For instance, the EESSI solution is really nice. It's perfect for a public solution. But in pharmaceutical companies, it will not work. Why? Because they have sometimes self-developed databases that has secret or confidentiality laws on top of it. They have restricted or custom internal developed software that cannot be distributed outside of their company itself. They also have security concerns. They want to have a total control of the Appstack that they are using because there are some security concerns about public stuff, and they want to ensure to have reproducibility. In this case, at least for 10 years. So public Appstack will not match or will not ensure this will not fit these needs. So what we do? So we have been working using GitLab CI/CD, continuous integration, continuous development task, to provide the Appstack. So we have a user request, then we create a MERE request using the GitLab interface. In this MERE request, we put an EasyBuild recipe or a request for it. And then the GitLab CI/CD will build the package for all the available architectures that we have in this client. And then this testing, so this software is distributed via CVMFS across the cluster or via CVMFS for the external clients outside the cluster. The users will test the software to validate it. And then we go to the second cycle. In the second cycle, a partner of the application group will do a peer review. We'll check the EESSI build recipe, we'll check the binaries, we'll check everything here. And once he approves, the package is merged, and then it's moved to the production. So once we have software in production, it will remain in production until deprecation, unless there are some security concerns. If it's needed, it's removed. With this pipeline, we have deployed 300 applications plus dependencies, so it's close to 1,000 applications. So and this is really helpful for the scientists. They have been using this along for 3 years, so and they are really happy with it. And we are having each time more demands to include software into EESSI because into this EESSI-like solution, because they can test it in the laptops, then they can move easily to HPC without having a large effort during the migration. So this is helpful for them. What about the restricted software? So the restricted software commonly are, this is an example of it, have 3 main components: the software itself, the license file, if it's needed, and the database. So the thing that we do is we split it in 3 pieces. So in such way, we put it in a CERN CVMFS folder, and then the user connects to the CVMFS client and pulls the information there. So at the end, the user have a complete set of the application plus databases plus licenses. Why we decide to split it? Because license files used to have a short life than the software itself. So we have to update it, or even the databases. And making a complete update of a packages just because a license change is time-demanding stuff. One of the nice things to have it split in that way is that we have access control, a complete access control. We can ensure a user have access to this application, but not to the other ones. So it's something nice in this solution. So how the users will use this Appstack? As I mentioned previously, we rely on LMOD, that is modules, a modules tool. So this is a common case. So we have a set of applications that are in the common Appstack, that is free open source software. So the compilers, Python, R, SnakeMake, whatever. And then the users can use organization specific, so a subset of applications that is just for their group. And also, they can also work on top of it, they can use a restricted set of applications. So it's a fully layered approach. So at the end of the day, the user can have a fully customized Appstack just for themselves. And this don't demand a lot of effort from part of the support team, because we just share the set of modules that they should load, and they can have it. How we can manage this layered approach? Because we have multiple repositories. One for apps, one for restricted apps, depending on the organization, and so on. In summary, with this approach, we have a Appstack that will work in cloud, will work in clusters, in diverse architecture software in the clusters, will work in the workstations, and even in the laptops. So this is so we achieved it. So, and thanks for your attention. If you have any question regarding this or regarding Do It Now, you can go to our booth and we can have a chat about it. Thanks.